Hi, we are Eduardo Chavez and Abdiel Vicencio. We are Team Orin from TechSem. In this video, we will show you the final solution to our challenge, a Puzzlebot that knows its location thanks to a Kalman filter and Aruco markers, and that navigates autonomously to a series of waypoints, avoiding obstacles. All of this runs on ROS 2 and Gazebo.
The robot has two ways to know where it is. The walls tell it how far it moved, but that error builds up over time. Like giving directions by cutting steps, the camera finds Haruka markers, special square codes placed at no spots in the world, and measure exactly how far and at what angle each one. The Kalman filter combines both. The wheels make a prediction, the market's correct. You can see that live in Orbis too. The leaves out around the robot rounds when it can see any market, and shrinks back when it finds one.
The system has 5 interconnect nodes. The Aruco detector controls the camera and transmits the distance and angle of each marker. The localization node applies the Kalman filter using the data and encoders from the wheels and reports the correct position. The waypoint monitor sends the next target once the robot reaches a stable position. The Book 0 or Book 2 modules handles steering and obstacle avoidance. We run 3 experiments. First, we use an empty world with 5 Aruco markers. The ellipsoid remains small and yellow throughout. Next, we test a Book 0 in a world with walls. It was faster, but the ellipsoid frequently turned red because the robot spent too much time away from the markers. Finally, we ran Book 2 in the same world with the same waypoints. It was slower, but the ellipsoid remained yellow and the robot reached each waypoint more reliably. The environment and markers were the same, only the algorithm changed.
The biggest challenge we faced was a race condition between the Waypoint Manager and Book 2. When a new tire was published while the robot was still in a wall following mode, the end line got corrupted. The robot would follow the wall forever because the progress condition could never be satisfied. We solved this by adding an EKF stabilization with each waypoint. The robot stops, waits up to 3 seconds for the covariance to decrease, then receives the next target. Another challenge was false positive Aruco detections. Textures in the simulation environment were being misdefined as markets. Since these had IDs not in our landmark map, the AKF simply ignored them, which is the correct behavior. In conclusion, the EKF with Aruco correction significantly improved localization compared to pure odometry. Book 2 provides more reliable navigation in complex environments. At the cost of speed, the combination of both gives the robot a robust and complete autonomous navigation system.
That's all for our solution. Thanks for watching.